Okay, so this is where we left off in class. We were talking about how to write the equation of a line, and when the book will give you different kinds of information and you will write the equation of a line. So we went over the one where the book might give you 2 points on the line, and then you use that information to find the slope and the y-intercept. This example is similar, except now they give you the slope and a point. So this one's actually a little bit easier than the one before because you already know what the slope is. You don't have to find it. So they give you that the slope is -3/5 and the line passes through the point -4, 7. So you know that your equation is going to be y equals -3/5 x plus b. You know m, that's the slope, so you can put that right there next to the x. But you don't know what b is, and so you can use the point they give you to figure that out. You're going to take that point, -4, 7, and you're going to plug those values in for x and y. And then you can write the equation, 7 equals -3/5 times -4 plus b. And now you can solve for b so that you'll be able to put it in the equation for the line. So 7 equals 12/5 plus b, and subtract 12/5 on both sides to get b, and get a common denominator. 35/5 minus 12/5 is equal to 23/5. So that is b. That's your b. That's your y-intercept. So now you have your slope, you have your y-intercept, and now you can write your equation, y equals mx plus b. So that goes in there for b. So y equals -3/5 x plus b. So whenever you're writing the equation of a line, this is how your answer is going to be. It's just going to be y equals m, the slope, times x, plus b, the y-intercept. Okay, lesson 13 is about using substitution to solve a system of 2 equations in 2 unknowns. So when we solve a system of equations in 2 unknowns, we're looking for values of x and y which will satisfy both equations at the same time. In math, equal quantities can always be substituted for one another. So the substitution axiom says that if 2 quantities are equal, replacing one with the other will not change the values of an expression, it will not change the truth or falsity of a statement, and it will not change the solution set of an equation. We often use substitution to solve a system of equalities. So we have x equals y plus 5 and 3x plus 2y equals 5. So we want to find a point, xy, that will satisfy both equations at the same time. So we have x by itself in that first equation, x equals y plus 5. And since those 2 quantities are equal, I can use y plus 5 for x in the second equation. I can substitute that. So I'm going to take y plus 5, which equals x, and put it in for x in the second equation. So I'll have 3 times x, which is y plus 5, plus 2y equals 5. And now I just need to use the distributive property. So I'll have 3y plus 15 plus 2y equals 5. And then add my like terms, 5y plus 15 equals 5. And then I'm going to subtract 15 on both sides. 5y equals -15 plus 5. And that means that 5y is equal to -10. So y is going to be -2. All right, so now I know what y is, but I don't have x. So I've got to go back and figure that out. So I know, because of back at the beginning, the first equation says that x is equal to y plus 5. And since I know that y is -2, I can figure out what x is just by putting that in for y. So -2 plus 5 is 3. So the point that will work in both equations is 3, -2. Okay, here's another example. You have 2 equations with 2 unknowns, and you want to figure out a value for x and y that will work in both equations. So this time, neither of the unknowns is by itself in either equation. So the first thing you have to do is isolate one of the unknowns. And in the first equation, you can do that by just getting y by itself, which is pretty easy. You'll have -y is equal to 11 minus 3x. So you've subtracted 3x on both sides. And then you can multiply through by -1 to get y completely by itself. So y equals negative 11 plus 3x. And now you can substitute that value in for y in the second equation. So you'll have 2x plus 3 times y, which is negative 11 plus 3x, is equal to negative 11. And now you use the distributive property, 2x plus negative 33 plus 9x equals negative 11. And then add your like terms, 11x equals 22. You added 33 on both sides. And then divide by 11 and you get x equals 2. And since you know that x is 2, you can find out what y is by putting that value in for x in the equation we just worked with. So y equals negative 11 plus 3 times 2, which is negative 11 plus 6, which is negative 5. So x is 2, y is negative 5, so your answer is going to be that point. You can check your answer quickly by just taking that point and putting it back into the first two equations that you started with. So the first equation, if you put in 2, negative 5, you're going to get 3 times 2 plus 5 equals 11. And that is true. 6 plus 5 does equal 11. And then if you put 2, negative 5 in the second equation, you're going to get 2 times 2 plus 3 times negative 5. And that's supposed to be negative 11. And that's true. 4 minus 15 is negative 11. So you can be sure that that's the answer. It does work. Okay, here's one more problem where we want to solve for x and y. Again, neither x nor y has been completely isolated in either equation, but we can go ahead and isolate x or y in that first equation. So if we subtract y on both sides, we'll have x equals 20 minus y. And now we can take that value and plug it in to the second equation for x. 5 times 20 minus y plus 10y is equal to 150. And now we can use the distributive property. So we'll have 100 minus 5y plus 10y equals 150. And then we can add our like terms. 100 plus 5y equals 150. Subtract 100 on both sides, and you will have 5y equals 150 minus 100. So 5y is equal to 50, which means that y is 10. And then you will take that value and plug it in for y in the equation we had at the beginning to find out what x is. And that will give you x equals 20 minus 10, which means x is 10. So you get the point 10, 10 for your answer, and you can check that in the original equations really quickly. So put it into the first equation, and you're going to have 10 plus 10 equals 20, which is very true. And then the second equation, you're going to have 5 times 10 plus 10 times 10 equals 150. So 50 plus 100 does equal 150, so it works. You can be sure that that is the correct answer. So the last part of lesson 13 is about finding the area of an isosceles triangle. So an isosceles triangle has two equal sides like this one here. It's got two sides that are both 5 and the base is 4. And we want to find the area. Remember, the formula for area is base times height over 2. And we have the base of this triangle, but we don't have the height. The nice thing about an isosceles triangle is that when you drop the altitude down, which is the height, perpendicular distance from the vertex down to the base, it splits the base perfectly in half. This only happens with an isosceles triangle, so don't try it on other triangles. But if you have an isosceles triangle and you drop the altitude down to the base to find the height, it will split the base perfectly in half. So the two halves here are going to be 2. Now, since we know how to find a missing side of a right triangle, we can see that we have a right triangle here where we know the hypotenuse 5 and we know one of the legs 2, and we can therefore find the other leg. So 2 squared plus h squared is going to equal 5 squared. And so 4 plus h squared is equal to 25, and then subtract 4 on both sides. H squared equals 21. So h is going to equal the square root of 21. So now we know the height of the triangle that we started with. So we can put that in there for the height, square root of 21. And now we can do what we were going to do to start with, which is find the area of the isosceles triangle. So we have the base, which is 4, and we multiply that by the height, which is square root of 21, and then we divide it by 2. So that is going to be 2 times the square root of 21 square centimeters.